Hi, today I will talk to you about my different collaborations with researchers from psychology and artists, especially restorers from Academy of Fine Arts and Design. So it is called XR in applications, but we will talk about computer vision, augmented reality, virtual reality, and how we can help with computer science as a whole to these different distinctive fields within human sciences. So, okay. So just to introduce myself a bit, I have done my PhD in augmented reality in cultural heritage applications. So I was always interested in both like XR and the cultural heritage itself. I'm working as well on like computer vision tasks as object detection, deep learning, and industrial applications. And on the side of XR or extended reality, I'm usually working on tasks of cultural heritage presentations, art and new media, but nowadays also with psychology interventions. So this area I will be talking about are under the big umbrella of this term called cultural computing. So cultural computing is a field that leverages computer technology and scientific methods to enhance, transform, and extend creative processes in culture, arts, and the social sciences. So in this area, I can really, under this area, I can put all of these different areas I'm collaborating and cooperating with. So in one hand, we can have like virtual therapy interventions I will be talking about later. But at the same time, I can put there also like our collaboration of Biennale of Architecture, which I have done in 2012. It was the installation in augmented reality in Czechoslovak Pavilion in Venice, where everything was installed just in AR. So the exhibition hall was just empty with only some markers, which were some texts made by architects. And when you point your tablet on the text, you will see the whole content only in virtual or in augmented reality, let's say. Then we also have collaborated in several like art exhibitions. For example, one in TEDx Bratislava, when we have created some interactive art for this artist, Jan Hrčka. And also before, when I was doing my bachelor thesis, I was cooperating with Academy of Performing Arts for some special effects to film of one of their students, Roman Fabian. So all these different projects can be really put under the umbrella of cultural computing. So let's first meet on the same terminology. So we will talk about VR, AR, MR, and XR. So do you know what these shortcuts actually mean? So what is VR? The virtual reality. Then AR, augmented reality. MR is mixed reality. And XR is like extended reality, yes. So when we talk about virtual augmented reality or mixed reality, there are also some other terms like digital twin. Have you heard about digital twin before? So what do you think the digital twin is? Okay, yeah, in some sense, yes. We have a special course actually on digital twins here at our department. It's like for master students of applied informatics. And the definition of digital twins we are using there, or my colleagues are using there, is that it's not only appearance, but also the functionality of some object which exists in reality. So we have some object in reality, and when we are building its digital twin, we are not only thinking about the appearance, but also some kind of simulation and also some kind of synchronization. So ideally, we would like to have the virtual twin, the digital model with all the functionality of the real one. And we can also simultaneously change some parameters in both, and they can synchronize, and the real one will work as the virtual one. And so it's quite complex term, but in this area, when we are talking, for example, about cultural heritage, we usually just need our digital twin to have the same appearance. So we are mostly just thinking about some photogrammetry and 3D reconstruction, so not the simulation itself. And then we have the terms like omniverse and metaverse and all these virtual worlds from different companies, you know. So when we are talking about this, we usually can think of it on some continuum. In this case, we can still work with Milgram continuum from 90s, which says that on the one hand, we have some kind of virtual real environment, and on the other hand, we have some virtual environment. And in between, we can say that somewhere here is the mixed reality. We can have augmented reality, which have some rules. And then we can have extended reality, which goes from here until the end, until the total virtual reality and total immersion. Also, what is interesting, there was added another dimension when we want not only to talk about if it is real, virtual, or somewhere in between, but we want also talk about how it works spatially and how immersive it is, and if it is just a desktop you are sitting in front of in one case, or if it is like fully immersive environment where you are like fully present in the virtual sense. So on the one hand, in like total virtual ubiquitous computing, we have these full virtual environments, and in like ubiquitous real environment, we can have ubiquitous AR. So when you think about, I don't know, like fridge, which will talk with you and synchronize with your shopping list, synchronize with your vacuum cleaner, whatever. So everything communicates with everything, and everything is a display, and you can really like interact with whatever is around you. So this is called ubiquitous computing. So computing, Internet of Things, everywhere computing, let's say. So in this sense, we can define virtual reality that is something which has this immersive experience, interactive environment, and some kind of computer-generated simulation. Augmented reality, on the other hand, has the definition that it has to fulfill these three rules. So the first is that it has to combine real and virtual world. Then the second one is that it needs to be interactive in real time. And the third one is that it needs to be registered in 3D. So if we talk about the real augmented reality and we want to place virtual Mac on our table, it needs to stay there even if we get around and look from different sides. It really needs to look like it's placed on the table and it don't flicker, don't move. Ideally, we want our virtual Mac to be also lighted by the lights presented in the room itself and has the shadows of our object and so on. We also want our virtual Mac to cover the things which are behind it in the real world, but this is like an ideal situation. We don't usually have this in like common AR apps. Also, like the augmented reality for the people from Slovakia here, it's very interesting that it has like really different translations. So I myself, I am using usually this rozšírená realita, and I was using it like for, I don't know, 15 years by now. But the problem is that nowadays the term extended reality is used, which is also translated as rozšírená realita, so that's a problem. Some I have found in the news that it's called augmentovaná realita as well. This is strange terminology, but whatever. In some faculty in Žilina, they use the name zmiešaná realita, which is mixed reality, so it gets mixed everywhere in Slovak language. We can have obohatená realita, which was coined in the FIT faculty. So everyone is using quite different terms. So luckily we are in English and we can use augmented reality and it's the same one. So that's nice. Okay. So this very crucial question, has your grandma ever seen augmented reality? So who thinks that his grandma has seen augmented reality? Okay, like one.
Is it a trick?
Yes. Okay. 1, 2, maybe. I don't know if you have raised hand. Okay. But I can show you that like all of your grandmothers has seen augmented reality before, because when we think about Olympic swimming pools, then usually these flags are placed on the swimming pool and it's combining real and virtual. It's correctly registered within the 3D environment, and it's also like kind of interactive in real time. If we think that real-time broadcasting is a thing, then we can say that when camera is moving, these flags are registered there, and you can see kind of augmented reality. So your grandma has seen it before, even if you think that she didn't. So for the virtual and augmented reality, what is interesting is that this field actually emerged in like 80s, but even VR even earlier in like 60s. So why is this hype right now started like in 2010, whatever? So why is this hype going on right now, even if the technology is quite old and methodology is quite old? So we can say that there are three different reasons for this. The first one is the hardware. So when the first augmented reality, virtual reality prototype was built by Ivan Sutherland, like the guy I was having the photo with several slides ago, his prototype was just one prototype at entire world. And he was a PhD student back then, and even other PhD students from other universities were not able to build the same prototype because the technology he was using some part was from military, some was from some television, and it was really hard and it was really costly, and no one was really able to build the same prototypes at their own institution. So this was a problem. So it went to sleep for several years until like in 80s, other people tried to build some prototypes of virtual and augmented reality. But still the hardware was very expensive, and it was not as available as it is now. So nowadays, 20 million plus Oculus Quest were sold. This is information which is several years old. So even it's more and more now. So it's quite affordable. And even at our faculty, we have several of these devices. Maybe some of you have some at home. Maybe someone. Okay, one, okay, two. Yeah. So it's pretty affordable. It's there. Also the applications. So comparing to the 80s, when just like computer graphics researcher, with PhD in computer graphics was able to develop some kind of application for these. Nowadays, it can take you like 2 hours. If you already knew Unity, it will take you 10 minutes to develop something for VR or for AR. If you don't know Unity, it will take you like 2 hours. If you already knew just a bit of programming to develop augmented reality app on your phone. So it's super easy, and it's there for everyone, and everyone can create their own content for these devices. So this is why it has gone from several labs in just very few places to everywhere. And then the users. So nowadays it's almost the entire population. So some like maybe your grandmother met this Steve Mann in 80s with this on his head, they will run for their lives. They will think that this is some crazy person with some very strange device on his head. However, since then, the way we perceive these head-mounted displays change a lot. So I put here this picture of myself wearing this kind of head-mounted device. So do you know what is it? What it was back then? Yeah, Google Glasses, Google Glass, yes. So this device was vaporware, so it was there for like 1.5 years, 2 years, and then it vapored because it was not very useful, let's say. I was just trying it at some exhibition somewhere, and they said that, yeah, we have this Google Glass, and since now you will never like read your message on your phone while talking to someone, because you will be able to just continue the conversation and really read all the messages while you are like speaking to someone else. However, the display was here, and when you want to read anything from it, you really need to focus there. So it seems like this. So you got the message, you really need to like focus on your display, then you can read the message, and it looked really strange. So it was not better than like putting your head down and like reading your messages on your phone. And I couldn't find like any really good applications for these. I have, like last year, I have actually go through the internet and searched like what was it good for? And I have found one application which was great. And it was like for teaching the first-time mothers how to breastfeed their children. So it used the camera, and they have seen what you are seeing, and you will call with like the special nurse, which is dedicated to teaching you this, like lactation assistant, whatever, and she will like instruct you how to do it properly. And I found that this is really nice, but like otherwise, I haven't found any interesting applications besides from that one.
The device was also like developed in half a day.
Okay.
At Google, they took some spare components from their labs and put it together with.
Okay. Yeah, I haven't heard about it. That's interesting, actually. Okay. So yeah, but yeah, it was vaporware. However, like there was a big shift in the consumers. So going from, oh, I will never wear this, which was my way of thinking about head-mounted displays back in like 2012. So I was like, oh, I'm really tech enthusiast. I love augmented reality, virtual reality, but I will never wear those in public, like never, never. And then they came with these nice ads, or with like very nice ladies going around with their Google glasses and looking really fabulous. And I was like, maybe one day I will wear these kind of head-mounted displays. So since then, there was a really big shift in the consumers' viewing of head-mounted displays. And then when the Apple came with these like swimming glasses, like it's really big device, and everyone was like, interesting. And it's because of the shift how the users really perceive these head-mounted displays since. So nowadays, the augmented and virtual reality is present here mainly because of these three things. The hardware is really available. Users think it's cool and great, and the applications are there and can be easily developed. So, but how we can use it and how we can employ the computer science and virtual reality or extended reality to help some researchers from other fields. So the first use case I would like to show you is the VR in psychological intervention, which we have done in cooperation with Faculty of Social and Economic Sciences of Comenius University, together with like several of my students and several PhD students from that faculty and their professor Julia Kanovska-Halanova. So they have contacted us before that they really want to work on virtual reality, which is kind of the trend in applied psychology. And there were different kind of interventions already created in virtual reality. So in this project we were working on together, we decided to work on two different interventions. One intervention was on forest therapy. So in this case, they want to compare the forest therapy versus city therapy and how it affects the personal emotional state and their self-compassion and self-criticism levels when they will be staying in virtual environment for like 30 minutes. And then the second intervention we were working on was like empty chair intervention. It is from emotion focused therapy, where you want to deal with someone who is like, it's called unfinished business. You have some problems with someone who can't be there for you. So you want to, you have some unfinished business with someone who is not present anymore in your life. So in this kind of intervention, you are sitting in front of empty chair and you are talking to someone who is not there. And then you switch places with him and you can then like see yourself talking in his position to yourself. So it's really interesting, and it is done without the virtual reality. So typically this intervention was made for just like normal setting where you have just these psychologists and you are sitting in front of the empty chair and you are changing the places. However, in this case, we can really make use of virtual reality when we can record your avatar, and then you can see yourself explaining what had happened, or you can see your avatar doing it. So it was really interesting. In the first case, we have published it at some conference. It's currently in print. And the second one was published in some journal, Internet Interventions. So it was really nice research. They have collected a lot of data. They have like 50 participants doing like 2 different sessions, which takes like 1.5 hours. So it was a crazy amount of work, which was done by their PhD students. So our work was just on the side to prepare the virtual reality. So in this case, to make it more immersive, we used full body tracking. So you have your head mounted display. So one tracker is on your head. Then we have 5 to 7. Then we decided to use 7 because the tracking was better. So you have 2 trackers on your hands, or 2 on your arms, then on your legs and around your belly. And then you have this kind of avatar. So we just have 2 avatars, one for one male and one female. We thought that it will be better or even necessary to have like customizable avatars, which will really be very similar to the person who is using them, or the person he's imagining sitting in the next chair. However, the psychologist told us that it's not necessary and that it's enough to have just 2 avatars. So they don't want to spend like more time preparing the avatars for each of the participants because it will take more time. So they said this is enough, and these participants are usually so immersed in their own emotions that they don't really care that what kind of avatar is there. So we have to solve different problems. For example, these persons, especially in forest therapy interventions, they are sitting in rotating chairs, and these rotating chairs are in real life. And they are rotating in real life, and we need to like match it with the virtual chair. So we thought how we can do this. So first idea was to put some tracker on the chair, but this didn't work as well. So then we create some colliders on the bottom part of the participant as well as on the chair. And when these things collide, the chair will rotate with the participant. So it was pretty nice, and the feeling was really like the rotating chair is rotating with you in the virtual and real time and reality. So it was pretty nice. Then we used 2 types in this case, the forest and the city therapy. So first, the participants are in the main room. We can put on their heart rate tracker. So we were tracking their HRV. And their heartbeat. We were also tracking their eyesight. So we were doing the eye tracking because the psychologist said that in the literature, it was proven that the person who is looking on moving leaves or flowing water will get like more calm than person who is not looking on these things and, for example, focus on the grass or the sky. So we wanted to know what amount of time was the participant looking at these like calming things. So we also employed the eye tracking in this. And then afterwards, the person was immersed in this virtual scene. So at first we tried 360 videos of both scenes. However, the resolution of the cameras we can achieve was not great. And when we create some preliminary study with few participants, they say that they will prefer the virtual reality. So at the end, the therapy was in virtual city and virtual forests. The whole scene was designed by the psychologists and creating by our students. And they also wanted to have animals there, for example. So in the forest, we have squirrels and butterflies, and in the city, we have rats. So you can imagine which one was more calming. However, the research, like the first part of the study with not full 50 participants, but just a part of them, I didn't have until now the full results, showed that it didn't make that much sense in the way of self-compassion and self-criticism, which were the factors they were studying. So it was similar, which was surprising for all of us, but I need to get to full results later. And the second therapy was the empty chair. It looks like this. So you are sitting on one chair and you are switching the places. This is the real environment. This is the virtual environment. You can also see the real reflection of yourself in the mirror. So there also were several problems that when we wanted to create the avatar of the person who is not present, we wanted to put some emotions on them. So we use some, motion track data from some library called Mixamo. But the emotions which were provided there, for example, there was problem with that there was an anger emotion presented there. And when we played this anger emotion, it looks like this. So it was really like an angry person, like at some crowd and shouting something, but it didn't work well in this environment. So in this case, we have to do our own motion tracking to create like better emotions, because this one was not very well presented. And like the first participant, we showed it to him. He was like, "Is he dancing? Why is he dancing?" So yeah, there were some problems with this project. However, we finally managed to get it right and to have like some nice results from all these interventions. Okay, so this was the first part of my presentation, which dealt with virtual reality for psychotherapical interventions. And in the second part, I would like to talk about computer vision and augmented reality for the restoration. So this, in this part, I will talk about several projects which we have done with our colleagues together with restorers from Academy of Fine Arts and Design in Bratislava. So why is it important to educate people about restoration? So are you familiar with this? So it was a meme back in 2012 to 15, and it circled around the internet. So there was this lady, Cecilia, who came to her local church pretty often, and she was like looking at this mural painting of the Christ, and it gets so worse and worse, like every week and month, getting more and more detoured. And she decided to grab the matter in her own hands and take some colors and paint, and she repainted the Jesus herself and created this crazy restoration. And yeah, you can see that she knows nothing about the restoration process, and she thought that this is better, that she made the Jesus great again. And yeah, so we thought that maybe it will be a good idea. So there was one restorer at Berger 2013 who came and reached me and said that maybe we would like to apply some computer graphics and computer vision to present like people from the audience with what the restoration process actually is and what are the different phases and what it means to restore some artifacts and paintings. So we think that it may be a good idea after this. And I have some question for you. So here we have some statue in the process of the restoration. And on the one hand, we have pre and post. So we have the statue before restoration and after restoration. So who thinks that I would like to ask what is after? So what is the result? So who thinks that this is the result will raise his hand or her hand? Okay. Okay. And who thinks that this is after? Will raise hands. Yeah. So that's just true. Actually, like this is the result of the restoration, and this is what it was before. And why is it, you may ask? So in the historically, the restoration was some process in which restorers were trying to achieve some ideal state of the statue. So they were trying to really make it as nice as possible to achieve some kind of this ideal state, which was at the beginning of things. However, nowadays, and sometimes they really match it to the taste of that time. But nowadays, what they are really trying to do is to get to the original painting. So get rid of all the layers and get to this raw material, which was at first on the painting or on the statue and want to conserve it as best as possible. So they really want to cover all the layers, to uncover all the layers and show us what was originally the treasure. So this is an example from Madonna, of the statue Madonna Skurova from second half of 14th century. So, and we want to help restorers with augmented and virtual reality to make this happen. So to show the general public how this is done and why is it done and what are the layers they are uncovering. Okay, so restorers think of their field in different terms that we as a computer scientist usually do. So they have different ways how to distinguish like photographs and wooden statues, documents, whatever. But yeah, we make it easier for us and think in terms of dimensions and what kind of methods we need to do to create this happen. So we decided to really divide it on 2D and 3D. So in 2D, we have paintings, documents, photographs, and 3D sculptures, reliefs, different objects, and so on. So we asked ourselves that what are the tasks? So what can we help with computer science? How can we help restorers with computer science methods? And we thought that there are 3 different, and I already added fourth one in my habilitation presentation, but yeah, it is missing here. So we have the restoration analysis, we have restoration documentation and digitization, we can have presentation, and we also can have digital restoration, because it happens a lot actually, and especially in the restoration of digital photographs. The digital restoration happens a lot, and it's because it can really be useful in different ways. So the first, when you have the old photographic technique and you digitally restore it, you can use it as a ground truth, and then you in reality restore your real photograph, so it will look like the thing you have created digitally. Then you can use the digital copy to be showcased, and you are just conserving the original and storing it in the depository. Or you can, when you are creating a book about the historical photos, you can conserve these originals and digitally restore digital versions and not just print them. And even there were some examples where there was a statue which was covered in photographs, and some of the photographs get destroyed by some humidity in the gallery, and they decided that they will create like digitally restored these photographs, print them again, and stick them on the statue itself, so they were like new originals. So digital restoration is also a thing here, but today I will talk about these 3 especially. So the first one is the restoration analysis. So restorers themselves are usually using some methods where they scrape some part of the photograph, of the painting, of a statue, whatever. They will take some sample in destructive method, and they will study it with some chemicals under the microscope and things and so on. So in this restoration analysis, we want to do some non-destructive methods and use computer vision and the whole computer science to help them analyze them without doing destruction on the objects themselves. So on one hand, we can do some documentation. So we can scan these originals in high resolution. We have this very high resolution scanner here at our faculty. We have used it in collaboration with some restorers, but also some people from which are doing some paintings and printing, whatever. It can be used really for digitize cultural heritage, 2D cultural heritage in very high resolution. It's used with Slovak National Gallery and national galleries all over Europe. So it's very high end. And if you need to digitize something, you can contact me, for example. If you have some project, then we can talk about it. The second, for the analysis, so when we have the scans, we can do analysis, which will be just using computer vision. So for example, we have this project St. Busters, which gets together microbiologists from Slovak Academy of Sciences, restoration guys, and us from here. And the goal was to create an app which will allow some people, for example, in archive, to just capture the photo of all document and get the bounding boxes of all the stains and ideally their biological origin. Because like trained restoration researcher who is focused on old documents, he can by naked eye distinguish what the stains are and what is their biological origin. And he or she can say that, wow, this stain will eat up your whole document in 2 months because it's growing, it will be growing and it's very dangerous. However, usually people in archives can't do it and they are going through all their documents in 1 to 5 years sometimes. So they haven't seen the document in 5 years. So in that time, we really want them to be able to send the document to restorers if they have some dangerous stains on it. So we wanted to create this. So we want to achieve it using some neural networks. And we can say, okay, easy task. We will just have some data. We'll train the neural network and we have it. So problem solved. However, the problem is the data because there is nowhere on the internet is some data set with the stains like this actually. So we needed to create it one ourselves. So we decided to do it in 2 ways. One, we have the real data set. So we have gone through the archive of Academy of Fine Arts and have found some documents, and then restorers annotated it with the bounding boxes and the origin of the stains. But by this, we have collected like 100 images, maybe 1,000 bounding boxes, so it's not enough. So we decided to also apply some semi-synthetic data set, which we have our microbiologists there. So they are cultivating stains on these small papers. So they can cultivate like hundreds of these stains. So they will just put something there and they have processes on this. So they have already give us the tens of samples. So they can do hundreds. And then we can segment them and put them on some already scanned documents. There are great databases, for example, Europeana, with lots of old documents scanned. So we can combine these stains with these documents and we can have this synthetic data which will be already annotated because we have produced them, rendered them with the stains. So using this, we will then train the neural network. We already have some results, but just for the 2 classes, the foxing and the feces of some animal species, which are also presented in the archives, unfortunately. And we can achieve like 80% accuracy on this. So hopefully, when we scale it to all the other stains, it will be working fine. So currently we are working on this. Okay. The second way of how we can help the restorers, I mentioned before, was the presentation. So in this case, for 2D, we decided to use eye tracking to present something which we called restorer's point of view. So we have our restorers to look at these old photographs which need to be restored, and then we record what parts of the image they were focused on. So then we were able to create this kind of height maps or heat maps, which were really highlighting the parts of the image which restorers focus on. And then we can compare how the normal person, non-restorer person can perceive these images. So this is also some kind of presentation of the restoration process because we want people to know where the restorers are focusing on. Because some parts which we think were like the very big damages on the photo, they were like, oh, this is not important. Like we are focusing on this. So it was very interesting to see how they can perceive these. Okay. But let's move from 2D to 3D. So in 2D, we were dealing mostly with photographic techniques because our main collaboration is there with the department which is focused on restoration of photographs and then documents. And then we are working with atelier, which is focused on wooden statues, or studio, which is focused on wooden statues. So in this case, we can also do the analysis, the documentation, and the presentation. So, but first thing, when we want to deal with 3D, we want to have some kind of 3D reconstruction of these. So we can achieve 3D reconstruction with all the different, several different techniques. We can have laser scanning. For example, this is the project Michelangelo, which was done in 2000s, and they used laser scanner to create a very high resolution 3D scan of Michelangelo's David. So this was done by the team of professors from US. So they came there to Florence and create this big project on digitizing different statues, and Michelangelo David was like the most prominent one. Then we can have the structured light scanner. So, for example, the first Kinect was one example of this. So you have some kind of projector and you have some kind of camera. It's usually running in infrared. So you are projecting infrared pattern and you are perceiving it with the camera. And based on how the pattern is disturbed, you can analyze like what was the depth in these areas where the pattern was, when the pattern was picturing, or where you can see it. So then we can have a time of flight version where you are just computing like how long it will take to the light to reach the point in somewhere in the depth and come back to the camera. So you know how fast the light travels. So then you can compute when you have the time it takes, you can compute what was the length. So how far was the point in the 3D space to your camera? So you can do the 3D reconstruction by this. But usually what is used nowadays in cultural heritage is photogrammetry. So what is photogrammetry? You need to capture a lot of photos around some object, and then you will put them together and create the 3D reconstruction. So first what you need to do is some kind of preparation and setup. So ideally you will have very diffuse lights, you will have the rotary table, you will have fixed camera, you can have like full black environment, or in this case it's gray. It was generated by Gemini model because I wanted to have like nice images with the same statue of Virgin Mary everywhere. And yeah, I got them from some big models. So the first you need to have a nice setup. Then you need to do the image acquisition. So you need to take a lot of photos. And in case you are digitizing, for example, professionally cultural heritage, like in Slovak National Gallery or other galleries around the world, you will need for this size statue like tens of thousands of images. And even I have seen that like for when they were doing pyramids, they will have like hundreds of thousands of photos. So it's like crazy amount of photos, and you really need to take photos around the object in like very small degrees, then do several elevations, also several rotation in each elevation. Then they are usually doing something which is called focus tagging. So you are doing it from the same position, doing different focuses. So it's very hard to process. However, if you want to do it like on your own, to do the photogrammetric reconstruction of something, you can take your mobile phone and you can just use some app like Polycam, and in several seconds you can have a 3D model. However, you can see that the resolution of this model you can capture with these is nowhere near something they can achieve with these thousands of photos in like national galleries in these special studio settings. However, it is possible, and we have done the workshop for the restorers where they can really like use these techniques like Polycam or these basic apps to create their own 3D reconstruction of their art or their objects they are restoring. So, yeah. Then when we have acquired all these images, the process of the photogrammetry is then doing some feature detection. So we will find some interesting points in the photos. So the interesting points are the points where usually corners where the intensity changes in different directions. So you will have these points, you will describe them by their surrounding, and then you will have do some matching. For both of these, you can use some standard computer vision techniques or some neural networks. For neural networks, there is some method called superpoint, which is great. If you need some interesting points, just use it. You can then use some feature matching. For example, this super glue method is very nice. It's like some neural network, some graph neural network, which is doing like great matching. Then you have to filter the pairs which were not correctly paired between the two images. Then you will need to do some camera pose estimation and then some bundle adjustment. So this is usually that you have pre-computed several positions from where the images of the objects were captured. You will have the 3D point in the space, and you will have to do some minimization of the reprojection error from these. So you will do this minimization, and what you get is some sparse point cloud. So you will get some points. Then in the photogrammetry process, you will have to do some dense point cloud. So you will go with some multi-view stereo. So I'm not really going into detail, just the whole overview from very top of how this photogrammetry works. However, if you are interested, there is a lot of literature on this, and yeah, I can give you some hints if you like to. So then when we have this kind of dense point clouds, we can have a mesh model. And then what we need to do is to do some texture mapping. So we need to have a texture on our objects. And then afterwards, we have our full model, and we can do some post-processing. So we can open it in some Blender, whatever, and get rid of some badly reconstructed objects which are there. We can also fill some holes, get rid of some parts which were not registered correctly, and we can export it to whatever formats we need to, like, show them somewhere or for further processing. Okay, when we have this 3D model, to help with the analysis, we can do, for example, multispectral textures in the process of 3D reconstruction. So sometimes, I think maybe you have seen it in the area of paintings where it was showed in the news even that we have found the special painting underneath the real one. So it can be done by CT scanning, but sometimes when you just have some drawn first part of the painting, which was drawn by the pencil, you can even see it with infrared imaging. So you are just using the camera, which is sensitive in the infrared spectrum, and you are using some infrared light, and you can see the layers which are under the top layers. In this case, we have this statue of San Sebastian, and he has painted veins. These veins was originally painted on his forearms. However, in 18th century, someone decided that this is too vulgar and they need to be repainted because no one wants to see the blood in the church. I don't know. But the restorers want to put it in the original state so they can see in infrared that, okay, the veins are there, and they know that how deep they can go with the cleaning process to spare the veins. Also with this is the UV fluorescence. So we are capturing the image in the visual spectrum, so with normal RGB camera. However, all lights is off. We are just lighting the object with UV light. So I think you have seen it in some parties, in some clubs, that you came there, it's black there, but something is like glowing, some fluorescent part of your clothes or whatever, your teeth, white parts are glowing. So this is the same what they are doing in restoration, that they want to see like what are the different garnishes, for example, that can look similar in visual spectrum. However, in the UV fluorescence, they will be different, and they will know that without doing the destructive process, they will know that these are different, and they know how different garnishes are reflected in the UV light, so they can go to the table and say, okay, this is not right, we need to clean this up. Okay, so for the photogrammetry, with one of my students, we have captured these 3 phases of restoration for these two statues. So we have in one case this Pieta, And in the second case, we have this statue of Jan Nepomucki. So he used the photogrammetry to capture the three versions of this statue. So this was done, and I have mentioned our exhibition, which is currently in Stara Pošta Gallery in Trnavka, and there you can see in virtual reality like both of these statues, so you can explore them in VR. And there are also like these different versions of they being restored there on the panel, so you can see this. Okay, and for the presentation, we have this one project of my student. I need to capture a nice video of it, but I haven't yet. This video is not very nice, where we would like to showcase these different states of restoration in something which we called virtual vitrine. So when we have a real showcase, it's just some frame and it's, for example, glass box, and the statue is standing in the vitrine, in the showcase. And we can have the virtual one where we have just a display, and the display is so-called view dependent. It means that it doesn't just show you one picture, but it is tracking your head, and based on the tracking of your head, it will re-render the object as if it will be standing like inside of the monitor, inside of the display. So as you are perceiving it from different angles, it will be re-rendered each time, and you can perceive it as it is inside. So this is just for one user. So it will be hard to do it for several users. It's impossible to do it for +2. In some settings maybe, but usually you are doing it just for one user and you are tracking his head. So in this case, we have our camera, which is running some neural network, which is tracking his head position, and then he's re-rendering all the time the object. Okay, and as a conclusion, I would like to say that it is important to educate the people about the restoration process. So we think this. So that's why we decided to work with the restoration guys. We think that also not even computer vision, but also XR, extended reality, can help with that. We also think that VR is a nice way to enhance the psychological interventions. And it was shown that it can help to decrease stress and increase self-compassion in their research. And yeah, I think the collaboration with researchers from different fields is very inspiring, but sometimes it's quite hard. It's hard to get on the same terms and to have the same language. So it's very interesting. And I think if you like art, psychology, whatever, you can go study computer science, and you can then revisit the field and bring your knowledge to them, and they will be happy, and you can even do like greater success in that area from the point of computer science maybe, or cognitive science as well. Okay, thank you.